Hello, everyone. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, everybody. Here with another session. Today, we talk about little bit about AI because everybody is talking about AI. So let's have a chance to talk about AI. But this talk is a bit different. So we have a special guest, James. How are you? Thanks
Good.
for accepting our invitation.
Yes, thank you for having me. It's great to be with you all. Maybe sometime I can
Thanks.
make it there in person.
Yes, that will be really our pleasure, and we'll be honored really to have you guys here.
Yeah.
So, guys, it's little bit about Java, Riyadh Java User Group. It's like it's almost like 2 years now for Riyadh Java User Group. We are like organizing sessions online, mainly sessions, but also we promise you to do so also in-person sessions soon. Uh, we had also a couple of sessions done like previously regarding LangChain for J and also a couple of AI stuff and also non-AI stuff. So if you are interested, you can go to our channel, Riyadh Jag, and check the previous sessions. A little bit about our guest today. James is a worldwide speaker, is also an author, an advocate working for AWS. For sure, like I will leave it to him to introduce us more about AI. I'm not sure that should we call uh, Java developers or should we call AI vibe developers or AI builders? I'm not sure which term to use. I'll leave it to you.
Yeah.
So, James, the stage is yours. We hope also, yeah, before we give it to James, please drop down the questions below here. So, in this session, we will, of course, have a chance to have the questions and answer. Yeah, without further ado, good luck, James. Hope you have an enjoying service. Thank you so
Great.
much.
And oh, how long do I have?
Yeah, you have 1 hour. You want to
Okay,
extend it,
great.
no problems.
Okay. Great. Yeah.
Thank
So
you.
let's dive in. Yes, I'm James Ward, Java champion, and do a lot of different JVM languages and technologies. So I've been doing Java for a long time. Also do Kotlin and Scala, and yeah, JVM is my home. And yeah, this is going to be about building AI agents with Spring and Java and MCP. So we'll dive into that stuff. Yeah, I work at AWS. I'm a developer advocate, so mostly helping Java developers learn how to build their AI stuff with Amazon and with Spring and things like Agent Core. So I'm also the Agentic AI Foundation Technical Committee representative for Amazon. So that's where the home for MCP, Agents.md, Goose, and Agent Gateway. And on the technical committee, we look at technologies that would be a good fit for the foundation. This is kind of like the CNCF of the AI agentic world. So, yeah, so let's dive in. I'll start with just some slides and some background, and then get into a lot of code. And so this is definitely a fun moment in the Java space, because we initially, you go back a few years, and AI years feels like much longer than that. But a lot of the AI stuff started coming out of the Python world, and there was a lot of the kind of AI ML specialists that were building a lot of the AI things. But one of the challenges with how we connect our AIs to our business applications and backend systems is that those generally aren't written in Python. They're generally written in Java and Spring. And so how do we take advantage of the AI stuff in the realm of our typical enterprise applications? So it's a great time to be a Java developer and learn the AI things and learn how you can integrate AI into your existing Java applications. And so, yeah, I think it's fun time for us to be Java developers and learning AI. So let's talk just a little bit about what an AI agent is, and kind of set the stage for what we're going to use Java for. So you may have tried to ask an AI agent something like, "What's the current weather?" And it'll respond generally with something like, "Hey, I don't know your location. I don't even have access to weather data. I can look up historical data that the model has." But this kind of question, whether it's asking about the weather or some business data that your backend application has, the model doesn't know that. And so what we need to do is figure out a way to integrate the AI models with our backend systems, all of our backend data. And so I'm going to walk through different approaches for how we do that, and different ways to set up those integrations. But before we dive into that, let's talk a little bit about what an AI model really is. The way that I look at it is that these LLMs are just these knowledgeable translators, so that they can take natural language and turn it into other natural language, or they can go from natural language to an image, or an image to natural language, or natural language to structured data, or structured data other structured data, or natural language to a programming language. And so they're just these models are just this aggregation of lots of knowledge, and then they can translate from one thing to another. And this is often done in terms of language. And so when we get to, that's the model side. When we get to agents, really the way that I look at agents is you kind of have three components of what an agent is. You have an environment, meaning access to something external from the model. You have, and that is typically like memory and other types of systems. You have tools that can then do things, fetch data, update database, that sort of thing. And then you generally give your agent some kind of goal, something that it's tasked with accomplishing. Then when someone sends a message in some way to your AI agent, what that is going to do is essentially just run in a loop. And so it's going to use the model, it's going to use the system prompt, it's going to use your environment and the state in your environment, and it's going to use your tools, and it's going to just continually try to achieve the goal using those things, the environment, the tools, and its stated goal. It's going to try to achieve what the user has asked it to do. And that loop is essentially the core of what the agent is, and ultimately trying to get to the end result that the user asked it for, given its stated agent's purpose. So let's take an example here of, let's say we have an AI agent for a travel and expense system. And our users may ask, what is our travel and expense policy? Or I want to travel from London to Las Vegas, and could you book some travel for me? Or I return from travel, now I need to file some expenses. So we've got the LLM, that model. We've got the environment, so our access to our data and the state of the conversation. And then we need a bunch of different tools in order to make this AI agent useful. And so maybe we have a find flights by route tool. Maybe we have a create expense tool. And so these tools together in that loop that I mentioned is what is going to allow our AI agent to actually do things. So the first part to being able to build an AI agent is what's called the inference API. And the inference API is just an API to talk to that LLM, that model. And so generally we can send text to the LLM and it's going to give us text back, or we can do all the things that we mentioned before, different ways of using that model to be able to send different things, get different things back out. And so I want to start with just some basic examples of Spring AI and the inference API that is available in Spring AI. And so we'll jump into some code and see what this actually looks like and run this stuff. So this first bean here is it's all going to be just command line application. So I've got my command line runner, and I need to give I need to have a parameter here for the chat client builder. And the chat client builder is our primary interface to the actual LLM model. So we have our chat client builder. The reason why it's a builder is maybe we have different instances of our chat client in a given application, and we want to be able to configure different things. And so the builder allows us to do that configuration. Then for some debugging, I have this logging advisor. We'll talk a little bit more about advisors later. But essentially what I do is I take my chat client builder and I set whatever parameters I want on it. In this case, not much, but we'll build some, we'll add some more parameters as we go. And then I call .build, and now I get my actual chat client. And what's underneath this chat client is some configuration, because we do need to tell this chat client what model to actually use and what provider. Spring AI supports a lot of different providers and a lot of different models, and the chat client is this like agnostic way to interact with all the different model providers. So in the world of AWS, the one of the ways that you can provide models and use them is through a service called Bedrock. And with Bedrock, what we can do is choose from like 250 different models. Those can be the Claude models or the Amazon models or tons of other models that are available on Bedrock. And those are all hosted for you. They run in your AWS account, so your data doesn't go anywhere else. It just goes to that model. And so for these particular demos, I'm using the Nova Pro model, which is an Amazon model, and then I have a parameter here for the max tokens. I don't remember. Let's see if we can see what the default of that one is. There is a default that's kind of low, and so I'm increasing it so that I'm going to be able to use more tokens. And we'll get into the other parameters that are here as we go. But so that's our basic creation of a chat client. And then when we have a chat client, we can then call it. And when we call it, we can pass it that text if we want, and then get the text back out. And so I've taken my chat client, I'm creating a prompt from the user. So that's something that the user has said. And in this case, my prompt is say hello. I'm invoking the chat client. So I'm doing a dot call, and then I just want to get the actual string back from the chat client. And so that's all that stuff kind of string together there to be able to invoke our model. I also have already set up my AWS credentials so that I can talk to that Bedrock service. And then finally, in this example, we're just going to print out what the model said. So let's run this one and we'll take a look at what actually happens here when we run this Spring application. So we'll see that the model, the message that was sent was say hello, and we can see the model response. So the model responded with hello, nice to meet, nice to connect with you, blah, blah, blah. So that's our kind of very basic inference example where we're using that model to send text and get text back. But underneath this is a whole API for talking to that model. And I did want to show what kind of more pull back the curtain a little bit on what the actual API looks like. So you can see, like, right now I'm just sending a string, getting a string back, but there's a whole API with lots of different parameters and things that you can use. And so let me switch over to now the debug version of this. And that's why I added that logging advisor, is so that we can see more details on what's actually happening. And so here's the whole kind of conversation API that's happening when I talk to that model. So we can see that I make a request, we have a message from the user, we can have some metadata about this thing, like the model we're going to use, the max tokens. There's other parameters that we can set, and we'll get into system message in a little bit. And so we can see that's the request, and then I get the response back, and there's some metadata in this, like how many tokens did I use. We can see the prompt tokens were 2 tokens, the completion tokens were 42, total tokens 44. Of course, this is all integrated with Spring's observability platform, so you can pump this out with open telemetry and to whatever you want, so you can monitor those kinds of things. But then because the model is able to do that while loop and be able to be aware of multiple messages, which we'll get into in a little bit, you'll see this very important finish reason end term. And what that's signaling to us is that the LLM has decided that it has accomplished the goal that we have given it. And so it said, hey, my turn is over. Now I'm kind of back to the user. And there's different finish reasons, which we'll get into later. But that's coming from the model to tell us what it is determined in terms of its ability to complete what the user asked it to do. So that's kind of what it looks like underneath the covers. And obviously Spring AI provides, this nice concise API for being able to wrap all of that conversation, all the API request, all the different things that need to happen underneath the covers for that to work. So that's our very basic example with the debugging enabled. But there's some other things that we can do with this basic inference API that I wanted to show you. So as I mentioned, we don't just have to go natural language to natural language. We can also go natural language to structured output. And so an example of this one, again, I've got my chat client builder, but now I've got a record called city. And a city has a name and a population. And then I have a string for food, which I've added this JSON property description of most popular food. And what is going to actually happen is we're going to send a message to the model, and we're going to say, hey, here's my actual message. I'm going to say, get the 10 biggest, get 10 big cities. And then I'm also telling Spring AI here to map the response to a list of city. And because I'm using generic parameters here, I do have to do this parameterized type reference, just a way to be able to get that generic type information. And the reason why that's important is because this list of city is actually going to have a schema, and that schema is going to be sent to the LLM, and we're going to tell the LLM, hey, when you generate a response, I want it in this form, which is the list of cities. And so underneath the covers, this becomes JSON schema. And then the LLM, when it actually responds with a JSON block, it's going to conform that JSON data to the actual schema that I've specified here. And so instead of doing the call.content, which gets me the string, now I'm going to get back here my var cities, which is going to be the list of city. And then to output something to the console, I'm just going to iterate through each city and display what it came up with. So let's run that structured output one, and let's see what that actually looks like when I call the LLM, send it that message to get 10 big cities, and we'll see what it comes up with. So it says that New York has, what is that, 8.4 million people and likes pizza. And let's see, Delhi has like 16 million people or something and likes curry. And so this was all from the LLM. So that was just based on what the model knew about cities and their populations and the food that they liked and that sort of thing. And so, but we did get that data back as now structured data. And so this can be an incredibly important part of our agent architecture, is maybe we don't just have text in and text out. Maybe there's certain parts of our AI agent that we actually do want to have structured data. And so this is on the output side. We'll get to kind of input side of data in a little bit. Yeah, so that's our structured output example there. And of course, Spring AI makes that nice and easy to be able to get data out as in a structured form. The next kind of basic inference API I want to show you is streaming. And so with streaming, what we can do is, instead of waiting for the entire response to come back from the LLM, we can get it in chunks. So as the LLM is returning data, we can get those into, in this case, in Spring, it's the flux, and we can see that here when we call .stream. .stream is going to give us a stream response spec, and then the .content on here is the flux of a string. And so that's getting us the text response, but doing it in a streaming API. And then in the Flux API, I can do that do on next and print it, and then wait until I get the final response out. So let's run that streaming one so we can see what that one looks like here. So when we want to run streaming, oh, my prompt was write a short story about the Java programming language. So now you'll see it's streaming the response back out. And so that kind of incrementally filled out. And so, if you're building an AI agent, like a chat client type of thing, then streaming output can be, just something to give the user something, without having to wait until everything has been fully completed from the LLM. So that's our streaming API. And that's great. But now let's talk about how we start to give our AI agent its agency, something about it, what it does and who it is. And so we typically do this through what's called the system prompt. And in this case, my system prompt is "You are a Wookiee." So that's, if you know Star Wars, the Wookiees in Star Wars, like Chewbacca is a Wookiee. And so now I'm going to send a prompt like I had before, say hello, but now with the system prompt, it should now be in the personality of a Wookiee. So let's give this one a try. So let's run our system prompt example. And now when I run this one, again, I'm just going to get the text back out, but hopefully it should be in the tone of a Wookiee. So yep, it's got some rumbling voice and a roar and that sort of thing. So great. So that's all just from the model. The model, is able to take that system prompt and know that is important and essentially do what that says. So in our like travel system example, our system prompt would be like, you are going to help users book travel and file their expenses and those sorts of things. So that's how we give it kind of its task. And this also helps provide a little bit of guardrails on what the agent can do. It isn't, the best guardrail system because people could find ways around it. And there's other ways to set up kind of better guardrails, but this does generally keep your agent focused on a particular task when you give it a system prompt. Okay, so that's our system prompt example, and you'll see how I'm just continuing to like take that chat client, use the builder to make modifications to what is kind of set up with that chat client, and then always invocation of that chat client is like we see there. Okay, so the next example is an example where, great, we've just used the model at this point. We've been able to send messages to the model and get responses back. But what about integration? As I said before, this is an important part of being a Java developer, is having all these systems that we need to integrate with. And so how do we start to integrate our AI agents with our data and our business processes and business systems? So first, I'll show you the example where we don't have access to something that we need. So an example of this is if we ask the model, what time is it? Let's run this one and see what happens. So this is the no tools example. And when I run this with what time is it, the LLM, it's just a model. It's going to say, hey, I don't have access to a clock. I can't tell you what time it is. And so now, in order to start building our integrations, we need another approach. And so I'm going to talk through a little bit about what that approach looks like with these models, and then show you some examples where we start to do these integrations. So the typical way that we take our LLM and give it tools, I'm going to walk through the actual kind of API that we use for doing this. So we've got our app or our AI agent. And if the user asks, like, what is the current weather in Berlin or what time is it? What we do is when we send a message to the LLM, we tell the LLM, hey, I've got some tools that you can use to help you accomplish the goal that the user is asking you to do. And so in this case, we tell the LLM, hey, I've got a get weather tool, and we give it a description. That description is important because the LLM needs to know in natural language what these tools can actually do. And then also included in this metadata is the parameters that are required to invoke this tool. So then what actually happens is the LLM will be like, okay, I need to get the current weather, but in order to do that, I need to call a tool. So the LLM then responds back to our AI agent, our app, and in this case, it uses a different stop reason. So before in that protocol, we saw the stop reason was end turn because the LLM decided it was done. But the other stop reason that the LLM can return, there's a few of them, but one of those is tool use. And in the response that the LLM comes back to our AI agent with, it's going to have some information about what it's trying to do. But then it's actually an instruction back to our AI agent to invoke a particular tool. Because the LLM doesn't have access to our tools, our app and our AI agent is what has access to the tools and the data and the business systems that we need to integrate with. And so now what's going to happen is the LLM has told it what tool to use and what input parameters to specify. And so now on our actual app side, we're going to invoke the thing that we said we have available, the get weather tool. We're going to give it those parameters. And then we take the result of that tool call and we send it back to the LLM. But we actually at this point need to include the first message that the user sent. We need to include the response from the LLM. So those two previous messages, the request and the response, and then we need to include a new message, which is, hey, I did what you told me to. I invoked this tool, and here's the result that I got back. And so we give that tool result to the LLM, and then the LLM will be able to take that whole kind of conversation history and be able to assemble a response like the weather in Berlin is currently sunny. And so that's how tool calling works. Most of the models now support this kind of protocol for doing tool calling. But this is what the kind of core foundation to building integrations with our AI models is this loop. It's a loop because we're going to get the response and then have to call back with the result from our tool calls. And potentially this happens 10 times, or it could happen, any number of times where we could be going back and forth with the LLM while it's trying to figure out how do I get to the user's stated goal given the tools that I have available. And so this requires the ability to track that conversation history, all the requests and responses that came back, and have that state all there. And so that's the foundation of our AI agent. And so let's look at, and then finally we get the response back from the LLM, that stop, reason, end term, with the summary that the LLM has come up with. And so that's how the tool calling works, and we can give that back to the user. Okay, so let's look at how this actually works in Spring AI. So first, I've got a tool, and my tool in this case is get the current date and time in the user's time zone, and it takes no parameters. It now just uses Java APIs to get the current date and time, and that's all for my tool definition. You'll see that I've used that annotation there at tool. So now let's see how we wire this into our chat client and use it. So with our chat client, we now can say, here's some tools that I am giving the LLM access to. In this case, I just said this, which is going to take anything annotated with at tool and provide that as tools to the LLM. And so now when I go ask the same question, what time is it? Now we'll be able to have the LLM say, all right, I want you to use your get current date time, and be able to then provide that back to the LLM. So let's run the basic tools one. And I'm going to run this one in debug mode so that we can actually see kind of what's going on underneath the covers here. So this is the basic tools debug. Now, when I run this, we'll be able to see this kind of full conversation history as it's happening with that logging advisor, logging all this out. So we'll see, here's my initial request to the LLM. You'll see in here as we go through that there was this additional metadata that was provided in the request that we made to the LLM, which said, here's the tools that I have available. I have the get current date time. Here's the description. And then here's that input schema. The input schema is the parameters that are required. And in this case, this should just be empty. There's no parameters required for this particular tool. If I had parameters on this tool, then the LLM would know about those. Okay, and then let's see what happens. So we make that request. You'll see that I'm logging that I have that tool available. And then we get the response back. And the response, finish reason tool use. And then we'll see that we get the text is, hey, I need to find out the current time. I'm going to use so that's kind of just a debugging information from what the LLM is trying to do. And then we'll see that, okay, that response comes back. It's saying, all right, I need you to invoke the get current date time tool. And then we're going to send another request to the LLM. And this time we take the previous message, the what time is it? we take the tool call response, and somewhere down here we'll see what the actual result from calling that tool is. So we see what that tool call resulted in, and we give that to the LLM. And then, same sort of thing is we also include again the tools that it has available, and that's because it may, sequence multiple tool calls together. And ultimately, we get back a response, and the response from the LLM this time is finish, reason, end turn, and we get now the LLM has taken that the previous, the request information that included the tool result, and is now formulated that into the nice text version of that there for us. And then we see that printed out finally there at the end. So that's our kind of basic tool calling example, where the same chat client has that looping, has the kind of AI agent capability in it to do those multiple calls to the LLM, handle the tool calling for us. So it handles the tool use response, it invokes the tools for us. And so same API, but this time using tools. Okay, so that's kind of our basic tool calling example. And you can build your integrations in exactly this way with @tool annotations and give those to your AI agent. And that'll work just fine for doing your kind of basic integrations. But you can also use something called MCP. And you may have used MCP in the context of your AI code assistant. And MCP, what it does is create a standard protocol for how we define and expose tools to our AI agents. And in this case, I'll hop back to my properties file here. I have set up the MCP client connection to, I have this javadocs.dev MCP server, and that's just a publicly available MCP server that serves information about Java libraries that are in Maven Central. And so I've just given it that URL. And what happens now is we can wire in to our chat client this tool callback provider. And the tool callback provider is this like automatic handling of the tools that an MCP server exposes. An MCP server can expose many different tools. And so we just have in Spring AI this super easy way to take all the tools that are available on that MCP server and wire them here into our chat client. And so now my prompt is going to be, what's the latest version of the WebJar's Locator Lite library? And there's a tool that knows how to resolve that and get the latest library. So let's run the MCP tools one and see what that looks like. Again, I'm going to run it in debug mode, and so we can kind of see what all is happening here. There's a lot of output, but let's scroll here from the top. So we've got our message, give me the latest version of that library. We've still got the current date time tool there, but now we have some additional tools like get latest version. Get latest version has a description, and then this one does have an input schema. We need to know the group ID and the artifact ID. Both of those are strings. Both of those are required. So we can see that input schema there. And we have a bunch of other tools here like get Java doc index, content list, symbol contents, source contents, list source contents, search artifacts, symbol to artifact. So now we've got a bunch of different tools. And you'll see once we get down to the response, here we can see the full list of tools there. When we get to the response, we'll see that, again, the LLM is responded with, I need to use a tool, and it is decided that the tool to use is down here, get latest version. And the LLM has decided how to formulate the group ID and artifact ID in order to invoke, for us to invoke that get latest version. So then Spring AI is going to do that invocation of that tool, which in this case, that MCP server is a remote server. So it's going to do an HTTP call to the MCP server. It's going to tell the MCP server to call get latest version. That MCP server will respond. And then we can see if we keep scrolling, the actual response that comes back is that. And so that's what the MCP server responded with. So we're going to then take that response, give it back to the LLM. And then if we keep scrolling through all this, we see that finally the LLM formulates its response based on the tool call, and it's now summarizing and saying, hey, the library you requested, the latest version is 1.1.3. And so now you can see how we can take MCP servers, whether those are MCP servers that other people have built or ones that we've built, and now we can do kind of like a microservices approach to how our AI agent will do these integrations with our external systems. So that's tool calling with MCP servers. Okay. But you may be wondering, there was a lot of data that was being sent with every request to the LLM. And so what do we do about the fact that we may have lots of different tools? If you have 10 MCP servers and each of those has 10 tools, then every single request that you make to the LLM is going to include all 100 tools from all of those. And there's some downsides to this. One is that it gets harder for the LLM to reason about which tool to call when we give it a lot of different tools. Maybe the descriptions are somewhat overlapping, and then also we're using a lot of tokens. The actual contents that we send to the LLM on every request it's gonna have a lot more data in it. So we're using a lot more tokens on the LLMs. So the typical approach to dealing with this challenge is that we do some kind of, we don't tell the LLM every single request all of the tools that we have available. We instead do potentially a semantic search. So we tell the LLM, hey, the only tool that you have available is a search tool, and that search tool is going to, we'll tell the LLM, hey, we can do lots of different things. Maybe even provide some short descriptions or something like that. But we say, let me know if you're interested in a tool, and I'll do a search on my side, on the agent side, and find the tool that's going to help you accomplish your goal. And then on the next request, we're only going to include the tool list of the search results. And so that's just semantic search across all of our tools. There's a couple other approaches. There's a framework called Embabel from Rod Johnson, who created Spring, and he does some interesting things with his ability to tackle this problem. One of those is called unfolding tools, which is kind of like creating a dynamic hierarchy of your tools. And then you can also have tool groups that allow you to kind of granularly control on a given chat client, only use this group. So there's some different approaches to how we do this. But let's check out the tool search tool and see how this works with that. So one of the tricks to doing semantic search is that to do semantic search, what we need to try to do is match the user's prompt to a given tool. And that semantic search we can do in Spring AI using a vector search. Vector search, what it's going to do is we're going to take our descriptions of our tools, and then we're going to take the user prompt, and we're going to try to find the most similar match between those things. LLMs have another mode that you can run them in, which is called embeddings. What embeddings do is they take a string and they turn it into a vector representation of that string. And once we get to a vector representation of that string, we can do a very easy mathematical operation, which is usually a cosine similarity search, that will take two vectors and then tell us how close those two vectors are to each other. So this is just an array of numbers. We get two arrays of numbers, and we can see by comparing these, comparing two different vectors, how similar they are. And then we can have our tool search tool be able to pick the tool that was the closest match, and then only include that particular tool in its list of tools. And so in order to create those embeddings, the vector representations of our tools, we need to set up what's called an embedding model. And back to our application.properties, Bedrock and other providers have ways to have access to an embedding model. The one I'm using here is the Titan embedding model, and this one is just going to take that string, turn it into the vectors, and that's all that does. And of course, Spring AI has built-in support for being able to call the vector model. And so, so what's going to happen in this case is I'm still giving I need to give my chat client access to this tool search tool calling advisor. And the advisor is essentially an interceptor for the requests that come into the, before it reaches the LLM, and then the responses that come back from the LLMs. And so this is a standard architecture in Spring AI for how we provide kind of different extension or places that we can hook into this life cycle with the AI. So we've got our tool search tool calling advisor, and I need to give it a place to be able to go look for in the arrays of all of our tool descriptions. So I've set up the my tool index here, which is based on a vector store, and I need to have a place to store all these vectors because that's I don't want to have to regenerate the embeddings on every single call, and so I want to store the list of tools that are available, the representations of those. And so I'm setting up this simple vector store. You can also use many different vector store implementations in Spring AI. You could use PG Vector, which is an extension to Postgres, or many other options for how you actually store those vectors. And then the vector tool index is a way that we can wrap that up, and that's going to be able to provide the actual search against that store. So we've set up our tool search tool calling advisor. We've told it I just want max results of 1. And then what we need to do is actually set up our advisors. And I had to do a little bit of trickiness here to set up how the advisor chain works because of my logging stuff that I've got here. But okay, so now let's see how this all comes together. I've got my default tools, which is a list of many tools, and we can go look at all of my different tools that I've provided. And these could be tools from MCP or your local tools, whatever those may be. But you'll see I've got lots of different tools that are being provided. And then I add my advisors, which includes my tool search tool advisor. And now let's use our chat client. I'm going to say, get me a random string 8 characters long. And I do need to specify a conversation ID there for this to work. That's just giving our advisor some kind of state handling there for the state that's kind of underneath all of this. And then I'm going to call the chat client. And then let's actually run this thing and we can see what's going to happen underneath the covers. So let's look for our tool search. And I'm going to run this one in debug mode so we can see what actually happens as this conversation with the LLM unravels. So the first thing that happens before we get to that is we had to create the embeddings for all of our tool descriptions. So each of these was an invocation to that embedding model to go from the description of the tool to the vector representation of it. So we generate all those, we store them into our vector store. We'll see that it indexed 21 tools. Great, so we've got those all in index. So now we send our message. And if we look here at the tools that we tell the LLM it has available, we only give it the tool search tool. And the search for what this is saying is, hey, I can search for tools when you need something that's not provided by your model. Then let me know, and I'll do the search of my tools. And there we go. So okay, so that's our first tool that we've defined. Then the model responds and says, hey, I need you to use a tool. And the tool that I need you to use is the tool search tool. And I'm just looking for one tool. And I'm looking for a tool that can generate a random string. So the LLM came up with that description of the tool that it's looking for. And so then what actually happens on the Spring AI side is it uses that vector search that it has to search our list of the embeddings, the vectors, and find a tool that can generate a random string. And so then it found the right one. Dun, dun, dun. Here we go. We see in the next message to the LLM, we have our list of tools, but we tell it, hey, I've got a tool called random string. And random string is a tool that you can use to now accomplish your goal. So I've told the LLM on this subsequent call that it can now use this random string tool. And then the LLM is going to respond back There we can see the tools that are available in the second column. It's going to now respond and say, hey, now I would like you to use the random string tool and give me a random string of length 8. So then the Spring AI invokes that particular tool, and then we can see, we're looking through the whole entire conversation history. You can see how these conversations, the longer they get, the more tokens we're going to use, because all this stuff gets, builds up on every single subsequent request. But now we can give it the LLM, our random string, and the result that we got back from invoking that function. And then finally, the LLM is going to assemble all that information and going to say, great, here is your random string. So the nice part about this was that we didn't have to include all that giant list of tools on every request to the LLM. The downside was that now there was an additional loop with the LLM to do the tool search tool. And so that's, one way that we can kind of tackle that bloat of the tools that we may have in context. Okay, so that's tool search with our with Spring AI, and of course that is all just included in Spring AI. The tool search tool is there. Okay, so now let's go on to next integration pattern, which we have, which is skills. Agent skills are a standard for how we can provide knowledge to the LLM. So tools are usually used for providing the ability to access, data that may be in a database or behind a REST API or whatever, be able to manipulate that data. We can authenticate to our tools. We can preserve the user authentication. And so tools can be authenticated. But what if we just want to provide some knowledge to the LLM? Well, skills are a typical way to do that. You may have used those in your AI code assistant. So I want to walk you through some examples of how we can integrate skills into our agent as well. So let's take a look at some code examples here. So we've got the basic skills, and I'm going to show you, there's a few different ways that we can integrate skills in. Essentially, skills are just files. So we can go look at the skill.md. Skills have usually a name and a description. They can have other metadata, and then they have usually markdown formatted content, which is the additional knowledge that we want to be able to send. And so this one is from presentation that Josh Long and I do about adopting pets with AI agents. And so we've provided some additional knowledge that we have about the pets that are available in our Pooch Palace adoption service. And so there's different ways that you can load those in. You can just pass the whole entire skill file every single time. That would use a lot of tokens. And so there's a way to do on-demand skills. And there is a skills tool in Spring AI, which allows us to have a tool that essentially does search across that name and description of the skills that we have in our class path or on the file system or wherever, and allows us to then provide a tool to the LLM that says, hey, I've got skills that can do these 5 things. Let me know if you want me to get you all of the contents of those skills. So then the LLM can respond and say, okay, get me the my skills dog skill, the dog breed skill. And then at that point, the tool would respond with the full contents of the skill, give that to the LLM. And so we can do that based on class path resources. I'll just run this on-demand skill one so you can see what this all looks like. So let's search here for on demand and run that one. So we should see what kind of similar to what we've seen before. We're going to make a request to the LLM. We're going to say, hey, we've got a tool that can help you get information about dog breeds. And then the LLM will respond with, great, get me the information about Chihuahuas. And then we say, great, okay, here is now your full kind of contents of that skill. And then the LLM can then respond with, let's pop down to the bottom, is some content that is only in this skill, it's not in the model, is what does a Chihuahua say? How does it talk? And that's down here with right here, how to speak. And you'll see that in my skill file, I've got the information about what a Chihuahua sounds like. It sounds like Chihuahua. And so now you can see that the LLM now had that knowledge that came from that skill file when it responded. So great. So we can load those skills kind of on demand. And in a business context, this could be skills used for policy information, could be process information. So a lot of times in our skills, we encode sequential steps for what to do in what order, that sort of thing. And so great. So we can take those skills and use them now in Spring AI with our AI agent. But we can also take those skills and we can have them be not files in a directory or on the class path. They can also be dependencies. And so there's a project that I created called Skills Jars, which is just a standard way to package up our agent skills and put them into Maven Central or wherever you have your JVM libraries. And so now I've got this Pooch Palace skill and I've included it as a runtime dependency. And so then what we can do is give it the class path resources to meta and skills. That's where the contents of our skills come from. And then just like before, we're giving it the skills tool. And then we can ask it questions that are specific to the knowledge of the skills from that skills jar. And we can see down here, if we look at, let's see, what's my dependency was Calm, James Ward, Pooch Palace. We can see the actual skill file here. I've got skills for dogs and cats. And here's the actual contents of that skill that get pulled in. So just a different way to distribute and consume our skills. More information about that at skillsjars.com. Okay, so that's an integration with skills and definitely a useful part of our AI agent architecture. But one of the challenges that we have when we're building our AI agents is how do we deal with memory? So if you think of a long conversation that a user may have in, let's say, a chat interface to the LLM, we don't really want to be piling up every single message that the user ever sent and the responses from the LLM and sending those every single time to the LLM. That would use a lot of tokens and create higher latency. And so what we typically do is we need to have some type of memory system that is going to take old messages essentially and potentially compact them down into smaller messages. Or maybe we don't care about old messages. We just want to do some kind of message windowing where we only send the last 5 messages or whatever it may be. And oftentimes in a real AI agent, we need to combine the short-term memory, like the windowing, the last number of messages, with some long-term compaction techniques as well. And so there's different ways to manage this memory. We can use other providers. We can use some tools that are built into Spring AI, like the auto memory tools, but we likely need to have some way to manage that memory across messages to the LLM. And so let's take a look at just a simple example of the built-in support for memory in Spring AI. So I'm going to go to basic memory. First, let's see this in the context of no memory. So with no memory, I'm going to call my chat client and I'm going to say, hey, my name is James, and I'm going to print the response. And then I'm going to call it again and I'm going to ask it, what is my name? And if you've used a good AI agent, this should work, right? You should be able to send these sequential messages and have the second message know what your name is. And so let's run this one, the no memory one, and we'll see what happens when we try this without any memory. We haven't plugged in any memory yet. And so when we run this, we'll see that it responds. The first response that came back is like, hey, James, nice to meet you. But then the second response is like, hey, I don't know anything about you. And so there's no memory in that case. It didn't remember me across those 2 different requests. And so that kind of shows the need for having some kind of memory system. So out of the box with Spring AI, we have the simple message window chat memory, and we can tell it how many messages to keep in context. And then what we need to do is create an advisor so we can inject into that call chain our interceptor that's going to have that memory. And then we need to give our chat client builder its advisors, which is the logging advisor that we need for logging, and then our memory advisor. So great. So we have our memory advisor set up. And now when we call our chat client, we're going to say, my name is James, but this time we give it the advisor parameter where we specify the conversation ID. The reason why we need that conversation ID is likely you want your memory just to be specific to a given user. If you're in an authenticated context, maybe you use the user principal or something here for your key into that memory. But then when we ask what is my name and give it that same conversation ID, then hopefully the memory is kicked in with the windowed memory and we see the response. So let's run the in-memory one just so we can see. Oh, did I not set up in-memory? Oh, let's do that real quick so we can see that actually work. Let's duplicate no memory with in-memory. And I'm using the Spring profiles to be able to trigger different beans here that get loaded. So let's run the in-memory one. And if I set up everything correctly, then we should see that I gave it my name, and then it should have actually remembered me, but something went wrong. So I gotta see what I did wrong on that. There's probably I just upgraded this project to the very latest Spring AI. And probably forgot to do something when I did that upgrade, but normally that should all work. And I'm using the message window chat memory here. This one is just going to be in memory, but of course you can take your memory and put that into a persistent database as well. And in that case, you provide a JDBC, place to store the memories. So all that's built in. I'll figure out what I broke when I did my upgrade. But hopefully that gives you the idea of what the chat memory is and how that works. Okay, moving on to the next kind of integration pattern here is called RAG. And RAG is kind of traditional way that if we have data that we want to insert into our conversation, instead of having the LLM ask for something, let's say we know that the user that's coming into, let's say, ask for their account balance, we know that they're probably going to need, in that context of that conversation, the account list that they have. And so we want to proactively add some data in. And this could be all sorts of different types of data that we want to proactively include in. But this is a similar integration strategy, but only for like read-only data, similar to tools, except that the LLM is not making any decision around when and how to call things. We're just deciding, hey, the user may need these things, and so we're going to include them. But we generally don't want to include all data all the time. And so typically what happens is we take the data sources that we may want to include, and we typically will do a search across the data that we may want to include based on what the user has asked for. And when we get a match from data that we may want to include and what the user has asked for, then we essentially inject that data into the prompt that's going to be sent to the LLM. So this is our typical RAG approach to things, and I'll show you how we do RAG here in Spring AI. So, like before with the with our tool search tool, we need a place to store the vectorized forms of the data that we want to include. So we have to set up a vector store. Then we have to add some data into our vector store. Typically, you would do this on a whenever the user inserts or updates some data, is when you would go update your vector store with the embeddings for those. But because I don't have a good way to do that in this particular example, I'm just at call time adding some data into our simple vector store, just our in-memory vector store. Then there's an advisor in Spring called the question answer advisor. And the question answer advisor takes that vector store that it's going to be able to search against, and we add that to our list of advisors. And now the data, let's go look at the data that I'm actually adding into here. So So I have my list of user accounts. So in this case, the user has checking account, savings account, credit card account. And this is the document that is the representation of each of those accounts. So I need to put that into a string. And then what actually happens when I do that vector store add is it's going to go use that embedding model and generate the vectors for each of those rows. And so then when we do the actual search, then we're going to be able to include those. Okay, so let's look at how this all comes together. Let's say that I have a prompt that is, what is the account number of my checking account? Oh, and you'll see I even did a typo, but the LLM doesn't care. It'll figure that out. What is the account number of my checking account? And then we do call.content. So to do this, we could do a tool that would provide access to this, but if we look at this prompt that the user is sending and we do a similarity search against our documents that are available in our vector store, then why not just include that data into the single prompt that we're going to send over to the LLM rather than having to make it go through a tool call? And so to do that, we've wired those together through the advisor. The advisor will intercept this call to the LLM, do that vector search of our vector store, and then include the accounts automatically for us because that prompt will match on the contents of the accounts, of the contents of the stuff that's in the vector store. So let's run the RAG example here and see this work. I'm going to run it in debug mode so we can see kind of details of what's actually going on. So first, you may have seen it scroll by, but we did need to, on adding those documents, you'll see that we called the embedding model, generated the vectors for each of those rows that we were adding. And now you'll see that the contents got augmented. So the content wasn't just the question that I sent with, but it also included some additional data. So you'll see that their Spring AI is the advisor is automatically added in my accounts into the contents that it actually is sending over. So the advisor augmented my prompt. This is the retrieval augmentation generation or whatever RAG stands for, to be able to augment the prompt with this additional data. And then we make the request to the LLM with those contents. And now we'll see that immediately on the first request, the LLM has responded with end turn because it was able to look in the context that I sent, the full message, and get my account number. And so it has said, hey, I have accomplished the goal. Here is your account number for your checking account. So great. So that's our typical approach to RAG. Lots of different ways that we can encode, different document types, all sorts of different things into our vector store so we have those representations. So yeah, that's our basics of RAG and augmenting prompts with some data. There's also ways in Spring AI that we can augment our prompt, not with this kind of manual approach, but let's say when we get the response back from the LLM, we want to actually be able to look up a record in the database to avoid hallucinations and that sort of thing. And so we can set up what's the document retriever is how we're going to actually search our vector store, and then the document post processor is what's able to actually take the response and do this enrichment of the data based on an actual database call to be able to, which we can go look at the enriching document post processor. What this is doing is seemingly like a database lookup call. In this case, I don't have an actual database. I just have my list of documents, but we can now correlate kind of RAG to records in a database. And so, so we with Spring AI can do the kind of, offline RAG or the online RAG with an actual database or REST service or something behind it as well. And then everything else is the same as what you've seen. So yeah, so that's our RAG, which is another important piece of the architecture for how we create these AI agents. There's one other concept I'll walk you through, and then see if there's any questions. But human in the loop can be an important part of our AI agent architecture, where maybe we want an MCP server or our agent to kind of figure out when it needs some more information from a user and be able to elicit that information from a user. And so the response will come back and say like, hey, I need more information on this. MCP has a technique to do this called elicitation, where the MCP server can actually say, hey, you didn't provide me all the information that I need to accomplish your request. Let me get that from you, and then we'll continue with the tool call to the MCP server. So definitely possible in your AI agent architecture to include the human in the loop pieces. There's also another way in Spring, which I have in my example here, which I won't walk all through just for time. But with human in the loop, we can use this ask user question tool, and we can essentially decide, all right, we've got the ability now to have a tool, which is our ask user question tool. And what this does is this figures out, based on what's happening in the context, do I need to ask the user for more information? And if we go look at the account selection question handler, this is how we actually wire a human in the loop handler in. This one is just standard in and standard out, but this will say like hey, the user asked a question about their accounts. I'm going to now ask them to select an account before I continue. And once they provide the result of that selection, then we continue with executing that. So yeah, and that of course uses an advisor to be able to handle that whole request flow. Okay, so that is human in the loop. I've got all this code up in a GitHub repo, which I'll get you the link for. So this is on my GitHub, so github.com, James Ward. And then if you go to my repositories and we search for integration, there is the agent integration demo. And that's where you'll find all the code I just walked you through. So yeah, check that out. Yeah, lots of different patterns for how we do that integration there with Spring AI. So there you can see all that. And that is it. Just to summarize what we walked through kind of being able to do basic interactions with the inference API, use system prompts, structured outputs. We walked through how to add memory with Spring AI in, walk through RAG, tool calling, MCP tool calling, and skills. So lots of different approaches and techniques that we can use when we're building our AI agent. Of course, Spring AI supports all that stuff really well. So it's a great time to be a Java developer building our AI applications and integrating them with our business systems and backend systems and that sort of thing. So, yeah, Spring AI has been great. You saw the link to the source code. If you do want to look up any resources, we've got a good one-stop Java AI guide, and then the Spring AI Agent Core SDK. If you do want to run your agents on AWS, there's a service called Agent Core. We've got a Spring AI library that makes it really easy to run to build your agents with Spring AI and run them on Agent Core. It's a managed serverless environment for running your agents. So yeah, and you can find me on LinkedIn and Twitter and wherever else. So so hopefully that was useful, and if there's any questions, let me know.
Yes, thank you so much, James. Really, really amazing presentation. Wonderful stuff.
Thank you.
We're really astonished with this capabilities of the Java and AI. It's really getting matured. Amazing stuff.
There's a lot there, and the first release of Spring AI was just over a year ago, and so it's moving quickly and adding lots of different capabilities for building AI agents.
Awesome. So let me take a couple of questions here. There's a question regarding the tokens, and if we have like more tokens, how can we what's the impact of the response and latency? What's the takeaways here?
Yeah, it's a good question. So tokens are just the element of how the LLM essentially constructs its takes your input and produces an output that's in the form of tokens. And the tokens are what you pay for. And so you pay for input tokens and output tokens. different models have different prices for input tokens and output tokens, and you can go look those up, on AWS or whatever your AI model provider is, and see what the pricing is. But the more tokens you use, the more you're going to pay, and so that's where managing tokens is a lot of the hard parts of building your AI agents. Is if you could just send 1 billion tokens on every request to the AI, then maybe that would make things easier, but you'd spend a lot more money. And so efficiently managing the tokens is a lot of the architecture of your AI agents. And so with memory, with RAG that only selectively includes data, with tool calling and tool search tools, those sorts of techniques are ways that you can reduce the tokens. Then there's the observability side. You probably want to be aware of how many tokens your system is using. And so Spring AI with Spring Actuator has the ability to provide your graphonometrics or whatever you're using for metrics and observability. So you definitely want to keep an eye and set alerts and those sorts of things, and set token limits. Like you'll see my default parameter was 5,000 tokens on, I think that was response tokens, or I can't remember if that's aggregate or response tokens, but you do want to, control limits and handle errors when you go over limits and those sorts of things. But, and then there is, as you get, another part of that question was, if you were to send the full max tokens every single time, you are taking longer to actually transmit those tokens over the wire. But then it also becomes kind of more information that then the LLM has to, parse through in order to get to a response. And so that's another reason to keep the token counts smaller, so that you're not like making it harder for the AI model to actually figure out what to do. If you have tons of different messages saying potentially conflicting things, it just becomes harder for that LLM to kind of assemble the response. And so definitely another reason to keep the number of tokens you send every time to as minimal a number as you possibly can.
Yeah, sounds good. I think if we are planning for enterprise application production ready applications, we should have something like limit the count of number of chats and the characters that shouldn't like bombard the LLM. So
Absolutely. Yeah.
yeah, sure. I think the other question related to the cost, I think was is already covered in the first one. So there is a question regarding uh, can we integrate memory with some cache server like Redis and this stuff?
Yeah, absolutely. Yeah. So the memory backends support all sorts of different options, and then you could of course create your own. So within Spring AI, there's many different backends that you can choose from for where you actually store those memories, and then how you decide to retrieve them. Then how you may do automatic compaction of old memories. Maybe the compaction is preserving some important facts, like the user's name is whatever, or they talked about this particular thing that was important. So yeah, but the actual storage place of those, you do want to be a durable storage. And so yeah, you can use a database or Redis or all sorts of different options for that.
Cool, awesome. Are there? I think you covered this. Are there any resources that we can go through?
Yeah, good question. So the Spring AI documentation is great. We also have let me see if I can find the link to this real quick. At AWS, we created a Spring AI workshop that goes through all the stuff that I just went through, but in more detail and hands-on. And so I've got the link for this. I'll send this to you. This one, I'll send the link here. Oh, hang on. Oh, looks like I need to. I forgot to log into YouTube, so I'm going to send this to you, and then you can share it in
Yeah,
the
I got
chat.
it. I got it. I got it.
Okay.
I got it. I got
Okay.
it. Yeah, I got it in the private.
Yeah, so that one, you can walk through. If you have an AWS account, you can walk through that one. If you we sometimes run customer workshops where we set up temporary accounts for people. And so if you are interested in that, reach out and we can see if we can get our account team or our solution architects to run you through that if you don't have an AWS account. But yeah, that's a great resource for learning more about that. And then at this point, there's tons of content out there, from blog posts from many different people about Spring AI. Dan Vega from the Spring team has a lot of great content on Spring AI specifically. And so yeah, there's at this point lots of different ways to get up to speed and go deeper on everything I just walked through.
Nice, awesome. Uh, in a short, from your experience and how, from the things that you've been observing, how the skills and agents are organized in enterprise applications and specialized as well. Is it like microservice? We have like a fine-grained, focused agent, focused skills, something like this.
Yeah, it's a good question. I think this is the hard parts of what we as engineers are doing, is figuring out the right architecture. And I didn't even talk about like multi-agent systems. So one
Hmm.
of the common patterns when you get into more complex systems is, how do you have your agent that just does this, but then maybe it needs to delegate to like another agent when it at particular times. You know, the user asked about this, I don't know about how to do that, but I've got this other agent over here that knows how to do that. And so for agent to agent communication, there's a few different ways that you actually would architect that kind of system. One way is you can actually do agent to agent over MCP. So you actually have an agent that's exposed through MCP to your other agent. And so then you can, talk to another agent just over MCP with tool calling. That's one approach. There's also the A to A protocol, which can be used for specifically for agent to agent communication. So A to A is another option as well there. So, and then how you actually then formulate the kind of mesh of agents is one of the more challenging architectural pieces. And there's different ways to do that. Some of the agent frameworks like Embabel have high level constructs for that agent kind of mesh. And sometimes it's like, just throw all the agents into the same place and let them figure it out. Sometimes it's, let's create a hierarchy of agents. Sometimes let's have like a way to search our agents and find the right agent. So you do like semantic search against your agents. So this is definitely when you get into the more complex architectural pieces that that take real engineering work to figure out how you tackle the complexity. Everything I showed today was the simple form of all that. But essentially, to go back to your point about microservices, is yes, we're building essentially microservices architectures, but our microservices are agents, and we have to find some way to bring those agents together and be orchestrated. And that orchestration piece is where things get hard.
Yeah. So microservices still are not dying, so still are there in the agent world
Absolutely.
in another
Yeah.
format. Yes.
Yeah.
Cool. So yeah, would you like to add something?
I saw a
Uh,
question on guardrails, which I was going to cover
yes,
real quick. So
exactly.
yeah, so
Yes.
in Spring AI, there's some out-of-the-box guardrails that you can use, and then Bedrock itself does have guardrails that you can set up as well. So when you actually do the invocation, the guardrails get applied on the cloud side of things, and then there's many different ways that you can set up those guardrails on the Bedrock side, depending on what you're trying to prevent or protect against. So yeah, a number of different ways. I think the prompt injection jailbreaking stuff, definitely look into the Bedrock guardrails, because that's an out of the box feature of those guardrails. So yeah, good question on that.
Yeah, cool stuff. And someone is asking, in your project, do you have files separated into basic chat, basic memory, RAG, and so forth? When moving these isolated demos to a real world production agent, what would you prefer?
I think that's one of those things that will take your all's expertise on your domain to figure out like how to take the different techniques that I showed and accomplish like what your agent needs to do. And that's the challenging parts, is like, Spring AI provides the foundation. How you actually build on top of that foundation to weave together RAG and skills and tools and all that kind of stuff together, like that's the tricky part. And it's very domain specific. Like there are production agents that don't use skills and don't use RAG, RAG and maybe only use tools, and then there's others that only use RAG. So it really is up to what it is that your agent needs to do, and you need to then figure out like which of those techniques is going to help me to best accomplish that, and allow for things like reducing token usage, and balancing all the constraints that you have. Like security becomes an important constraint. Is like, okay, if I need to propagate user identity through to the actual tool call so that when the tool call invocation happens, I know who the user is, like that's a design constraint that would lead you toward tools or MCP versus other approaches. And so yeah, I think it's all very dependent how you use all those different pieces on what it is that your agent needs to do.
Awesome. Someone is asking you personally, like, did you try the new ChatGPT Sol, which is better, Claude Fable or the new
That's a good
GPT
question.
model?
I have not tried any of those yet. Yeah, I'm still using. I use the Claude Opus like 4.8 a lot in my work and in the agents that I'm building and working on. But I haven't tried any of the new and exciting things yet. So I need to get up to speed on all the latest things. It all moves quickly, so hard to keep up. But yeah, lots of interesting stuff happening on the model side as well.
Yeah, amazing. Even now we have a big competitions in the open source world also.
Yeah,
we have
yeah,
so many good stuff like GLM 5.2, DeepSeek, and other stuff.
Yep.
Last question before we wrap up, James. Sorry, give us some brief about Cairo. Is the AWS, the Amazon product?
Yeah. So Amazon has a coding agent called Kiro, and it has the VS Code based IDE. It has a CLI. It has a web version. I think it has a mobile version that's coming or in preview or something like that, which I haven't even tried yet. And so this is something that you can use for helping you write code. I do use it a lot, and it works pretty well. So has all the things that I need, like MCP integrations and that sort of thing. So, yeah, if you are looking for a AI code assistant, then check out Kiro. I think it's just kiro.dev is
Yes.
the website there. Yeah, and check
It's
that
like
out.
a spec. It's spec by default, built-in spec development. Yes.
Yeah.
Okay.
Yeah, and there was a follow-up question on guardrails. There is a whole
Yes.
page in the Spring AI documentation around the Spring AI guardrails. And then, of course, if you're using Bedrock and want to look into the guardrails on Bedrock, you just set those up in your AWS account, and then you don't change anything on the Spring AI side. Like the guardrails get applied when you do that model invocation. So yeah, so you can do kind of client-side guardrails with Spring AI, or you can do Bedrock guardrails, and then those they just happen automatically on agent invocation. So you
Or
don't
we
have to
can have
change anything. Oh, you can do both.
approach.
Absolutely.
Okay.
Yep.
Like client-side validation, server-side validation.
Sure. Yeah, there you go.
We are back to software engineering. It's not dying.
Yep. Exactly.
Okay.
Still
Yeah.
lots of
So
fun problems to tackle.
we are not replaceable, yes, yet.
Yeah.
Okay. So I think we wrap up here. I really thank you so much, Mr. James, for this amazing session. Good questions. Thank you, audience. Amazing stuff. So I leave the final words for you, James, if you have something to say.
Yeah, thank you all for having me. It was great to spend time with you, and thanks for all the great questions, and hopefully I'll see you all in person sometime.
Yes, sure. Thank you, guys. Goodbye.
Thanks. Bye.